You know, in the digital world, the most dangerous threats, they're usually not the ones you see coming. They're quiet, they're sneaky, and they work by twisting your own trust into a weapon. So today, we are pulling back the curtain on two of the web's most powerful but often invisible villains: cross-site scripting, or XSS, and cross-site request forgery, also known as CSRF.
So let's just kick things off with a simple question. What if the very websites you rely on every day, I'm talking your bank, your social media, all of it, what if they could be turned against you, used as a weapon without you ever having a clue? Well, that's not just a scary thought, it's exactly what these attacks are designed to do.
To really get how these villains operate, we first have to understand the one fundamental rule the entire web is built on. It's a pretty simple idea, but as you'll see, it's also surprisingly fragile. The idea is that every website is supposed to stay in its own little bubble.
Now, this core principle has a name. It's called the same origin policy. And honestly, the best way to think about it is like this. Every website you visit lives in its own house, and it's got a big fence around its yard. This policy is the law that says the website in House A can't just reach over the fence and start messing with things in House B's yard. It's the bedrock of how your browser keeps you safe. But our two villains? Well, they found some very clever ways to tear that fence right down.
All right, first up, let's meet our impersonator, cross-site scripting, or XSS. This attack is an absolute master of disguise. Its whole game is tricking a website you trust into running malicious code, making it look like it's a totally normal part of the site.
Here's a great way to picture it. Imagine a village notice board where everyone posts messages. An attacker comes along and writes a malicious command on that board, but they use invisible ink. To everyone else, the message looks totally fine. But when you come along and read it, the hidden command suddenly appears and tricks you into doing something. That's exactly what XSS does, just with malicious code injected into a website you already trust.
So, let's walk through how this would play out on, say, a blog. First, the attacker posts what looks like a totally innocent comment, but they've tucked a nasty little script inside it. Second, the website's server, which has no idea there's anything wrong, just saves that poisoned comment to its database. And finally, you come along to read the blog post. Your browser loads the page, sees that script in the comments section, and because it's coming from a trusted site, it just runs it. Instantly. No questions asked.
And what could that script do? I mean, that function name, do something evil, is not an exaggeration. It could steal your session cookies right out of your browser, which would let an attacker completely hijack your account. It could act as a keylogger, recording everything you type, or it could even erase the real website and pop up a perfect fake, a pixel-perfect copy designed to trick you into giving up your username and password.
Okay, so that's the impersonator. Now it's time to meet villain number 2, cross-site request forgery, or CSRF. And if XSS is all about disguise, CSRF is the master forger. It's like a magician that makes your own browser do things you never intended, all behind your back.
See, here's the trick. CSRF doesn't attack you directly, and it doesn't attack the website directly. Instead, it abuses the trust the website already has in you. Think about it. Once you log into a site, that site trusts any command that comes from your browser. CSRF just exploits that trust to forge requests that look like they came from you.
Let's walk through this magic trick, step by step. So picture this. You're logged into your online banking website. Then you get an email with a link to a funny cat video. So you click it. That link takes you to the attacker's website. Now, you don't see anything, but hidden on that page is an invisible form that automatically submits a request back to your bank. And because you're still logged in, your browser helpfully attaches your session information to that request. The bank just sees a valid request from you, asking to transfer $100 to the attacker. And just like that, the money's gone. So let's just nail this down, because it's the most important difference to understand. XSS attacks your trust in the website by injecting bad code into it. But CSRF, on the other hand, attacks the website's trust in you by forcing your browser to send bad commands from it. It's a subtle difference, but it's absolutely everything.
And this is where things get really interesting, and frankly a little scary. Because what happens when the impersonator and the forger decide to team up? Well, the result is far, far more dangerous than either of them working alone. Now, you might be thinking, surely websites have a way to stop this, right? And they do. There's a common defense against CSRF called a CSRF token. It's basically a secret one-time password that has to be included with every important request to prove it's the real deal. So the question is, does that make a site safe?
And the answer, unfortunately, is a big, resounding no. This is the ultimate team-up.
A single tiny XSS vulnerability can act like a skeleton key, completely unlocking and bypassing what should be a really strong CSRF defense. Here's exactly how the heist goes down. First, the attacker uses that XSS flaw to plant a little spy script on the page. Then, that script runs in your browser, and its only job is to look at the page's code, find that secret CSRF token, and send it back home to the attacker. Now the attacker has the secret password. They can create a perfectly forged request, slap that stolen token on it, and the server will have absolutely no reason to doubt it. Game over.
Okay, that's the threat. It's pretty serious. So, how do we fight back? Well, since there's no single magic fix for this, the solution is to build a digital fortress. We have to create a defense that relies on multiple overlapping layers of security.
And this defense really rests on three main pillars. First, there's output encoding. Think of this like carefully taking apart a bomb so it can't explode. It makes dangerous code characters totally harmless before they ever get displayed on a page. Second is input validation. This is like having a really strict bouncer at the door, checking every single piece of data to make sure it follows the rules. And finally, security headers. These are basically direct instructions the server gives to your browser, telling it exactly what is and what isn't allowed to happen.
One of the absolute best tools we have in that last category is the Content Security Policy, or CSP. The easiest way to think of it is as an exclusive guest list for your website's code. The website sends this header to the browser and says, look, you are only allowed to run scripts that come from this specific approved list of places. See anything from anywhere else? Block it immediately. It's a fantastic defense against XSS.
And to make that guest list even more secure, developers can use something called a nonce gen. Just think of it as a unique, single-use ticket that a script needs to get in the door. Every single time a page loads, the server generates a new, random ticket and gives it only to the legitimate scripts. An attacker's injected script won't have the right ticket for that session, so the browser just flat-out refuses to run it. It is an incredibly effective way to shut down XSS attacks.
Look, if there's one thing to take away from all this, it's that security is not about finding one single silver bullet. It just doesn't exist. It's about a mindset. It has to be a proactive, layered approach, building that fortress wall by wall so that if one defense happens to fail, another one is right there to back it up.
And that brings us to one last, really crucial question for the future. XSS and CSRF, they're considered classic attacks because they exploit the fundamental DNA of the web itself. But as technology is racing forward with AI, with all these complex new frameworks, how are these old villains going to adapt? What kind of new disguises and new forgeries will they invent next? That's the question that everyone, from the people building websites to all of us using them, has to keep asking. Thanks for joining me for this explainer.